In this recorded part, we will be discussing about wave optics. So by now, you would have seen different nature of light, right? So for example, light in chapter 9, you know that it has been discussed as a ray, which is definitely in straight line, right? In this chapter, we would like to discuss the other nature of light, which is actually a wave nature. Okay, so this is going to be dealt in this chapter 10, and this was in chapter 9. And then, when both of them are cumulatively coming, you will be seeing that in the chapter 11, which is dual nature. Okay, so this is a different part which will come in the upcoming classes, lectures. But for now, we are going to see the wave nature. So, when you're discussing about the ray nature of light, you're always seeing that it is traveling in straight line, right? Whichever optical device you have taken in grade 10 light chapter or grade 12 chapter 8, you have always, chapter 9, I guess, right? Yeah. So, in these chapters, you have always taken an optical device like concave mirror or convex mirror or concave lens or convex lens, prism, slab. Okay, all these optical devices, you have traced the incident light as a ray. You have taken two rays as examples, you have applied some ray optic diagram rules, and then you have obtained the images, and on the images you have got to know about what is its orientation, what is its positioning, is it magnified, is it diminished. Okay, so all these discussions you have done with respect to the ray nature of light. But now, after ray nature of light, light is the most smartest thing that we have discovered so far. Okay, because it is actually having so many natures. If you see, ray nature, wave nature, and then in the third chapter when you come, you will get to know its photon nature, right? So just this one light has so many natures. Okay, so what happens is light basically believes that, I mean, not believe it. It changes its nature based upon the phenomena that's occurring. Okay, um, if the phenomena is of a certain type, it perfectly knows how to behave in that situation. Okay, so based upon that phenomena, so all these three, based upon the phenomena itself, we can understand light will behave in which format, in which type of situation. Okay, so this chapter particularly deals with the wave nature, so let's get into it. So the chapter starts with the most important discussion, which is going to be about interference. So about interference, I have few questions to ask you. What do you think it is going to be? So in physics, it's about two light sources. Okay, so for example, this is one light source and this is second light source. Okay, and now what will happen? You know that both these light sources will exhibit light wave. That was actually that is electromagnetic wave itself, according to your previous chapter, right? Which is chapter number 8, right? Chapter 8. So we need two light sources, and when you have two light sources, basically we are going to superimpose them. So what is superimposing them? Superimposing basically means we are trying to add them up. Okay, when you try to add them up, they give you a certain pattern on the screen. We need that pattern for our discussion. Okay, but for that, most important condition, if you want interference to see in front of you, you need to make sure that the phase difference of these both is actually zero or constant. Only then you will be able to see the sustained interference. What is sustained interference? Sustained interference means you'll be able to see the pattern on the screen for quite a while, so that you can go ahead with your observations. That will only happen if the phenomena is sustained. So just like reflection, refraction, dispersion, right, are all the phenomena of light. In the same way, interference is also a phenomena where we are adding up the light waves, the electromagnetic waves that are coming from two different sources, and we have taken sources with zero phase difference. Okay, so let's see how it works with an interesting simulation now. So here you can see that I have two light sources. This is first one, this is second one. Okay, and this thing What I'm highlighting now is the screen. So let us see, when light waves are coming from first source interfering with the second source, how are they superimposing? Let's understand how these waves are going to add up. Okay, so let's see the pattern, how it works. So if you see, this is how your first source is sending the light in the wave nature, right? Can you see anything happening on the screen? You can definitely see a mild green color appearing on the screen, maybe. Or maybe you will be able to see more pronounced results, as in like more visible results, when you see the interference happening. Because right now the interference has not happened. For interference, I definitely need two light sources. I have not turned on the second light source. Now I will be turning on, and once I turn it on, you'll be able to see how these waves are going to interfere, and then what is going to be the pattern on the screen. So here I turn on the second light source, and now you can see how these waves are interfering, and post interference, what kind of pattern have they formed on the screen. If you can see it properly, it's very important for us to observe this pattern on the screen. If you can see that this pattern is not very much green all the way, it has some bright spots, dark spot, bright spot, dark spot, bright spot, dark spot, right? So dark ones are the black ones and bright ones are the green ones, right? So what is happening over here? You can see that it is forming a fringe pattern. What is a fringe? Fringe is basically these. If you can see, I will show it to you. For example, this is a dark, sorry, this is a bright fringe of green color. This one's a dark fringe, right? This one's a dark fringe. This is a bright fringe. This one's again a bright fringe. This is again a dark fringe. This one is again a bright fringe. So basically all those green fringes are bright patterns, and the other where no light is able to be received on the screen are all the dark fringes, right? So this is how interference happens, and you can see the pattern. I'm going to increase the amplitude a bit if I can do that. One moment. Yeah, so let's increase the amplitude a little bit, and then you can also shift the gap between these two light sources. Okay, I'm going to increase it a bit and check now how it works. So here you can again see the interference happening, and you can also observe that now you are um, able to see more number of fringes, or more defined and pronounced pattern of fringes, right? It's more visible, more clear. Let's try to increase the distance between the two light sources and then check how interference happen. So here also, if you see, you're able to see even more number of fringes, right, when you increase the distance between the two light sources. So what have I done? I have tried to increase the distance between these light sources. Previously it was less, and now I have increased, and when I increase it, I'm able to see more number of fringes. As you can see, I'm highlighting all the bright fringes, and whatever I have not highlighted, all those are dark fringes. So this is how the superimposition happens in physics, and this is the interference phenomena observed on the screen. Can you see this pattern on our screen is very much sustained? You are able to see it, right? So that is only successfully seen when these two light sources, 1 and 2, are actually sending these light and have constant phase, or else have a phase difference of 0. So let's just understand how phase difference actually means, what it means, and from where it comes. Okay, because if their phase difference is not 0, you will not be able to see the proper thing. You know, all these waves are interfering basically, and when they interfere is we get the pattern. Okay, so what makes a fringe bright, what makes a fringe dark, is something that we have to discuss now. for explaining you what do you actually mean when two waves are having a phase difference of zero, I want you to understand few important things in the most easiest way possible. I'm trying to explain you. So for example, this first graph that I'm using is for time. Okay, so complete one wave has one crest and one trough, right? That means one higher peak and one lower peak. So let's assume this is the higher peak that I am taking. Okay, this is the higher peak that I have taken and this is the lower peak. So what will happen over here is, it will be over here, it will be t by 2, right? Over here it will be t by 4, and obviously over here it will be 3t by 4, and the full thing will be a t, because I'm just first telling you how it works with one whole cycle itself. Okay, so um, now if I'm asking you to take this in form of angle, how will you take it? So I have to use this values to explain you better. So I'm going to extend it below in the further graphs as well. So in angles, what is happening? You have a full circle of 2 pi, right? So that means this basically is your pi over here, right? And then this is basically 2 pi. And then you know that the other values will be, this will be pi by 2, right? And this will be 3 pi by 2, correct? Now when I'm using the same thing for length, I'll tell you why am I using length over here. You will understand. I'm taking length in form of wavelengths. Okay. One whole lambda is one whole wavelength over here, right? That means one crest and one trough. Crest is this, trough is this. Okay. The negative peak is trough. The positive peak is crest. So at that point of time also, this is lambda by 4, right? This is lambda by 2, and this is lambda by 3 lambda by 4, right? So when I'm saying you that two waves, okay, that are showing you interference have a phase difference of 0, which you have successfully seen. You have seen it over here, right? Over here you have seen it, how it is happening, right? So for this, what generally is going through, what generally is happening, these two light sources are having a phase difference of 0. Okay, when I say difference of 0, I mean, you take, for example, this is your light source 1, this is your light source 2. Both are in coherence with each other. What is coherence? Both are in sync with each other, which means here is the crest of this wave, here is the crest of this wave, here is the trough of this wave, here is the trough of this wave. Do they have any sort of distance or any sort of skipping that you are able to see, or are they actually lying with the same angle and same length? The answer is yes, they are lying in the same length and same angle, right? So right now I can say that this is how these two light sources are. Can you see which light sources I'm talking about? I'm talking about these two light sources, right? Light source 1, and this is my light source 1, my light source 2. Okay, so this is exactly what I'm talking about. So these two light sources are what? These two light sources are basically going to be having phase difference of 0. This is light source 1, this is light source 2. Okay, do they have any sort of distance in terms of crest and trough? No. Here is the crest C1, here is the crest C2, here is the trough T1, and here is the trough T2, right? So now when the phase difference is 0, we can tell that two waves are perfectly in sync. Their crest and troughs coincide exactly at all the points in space and time, right? So here we have two different cases, right? You can see, you must be having questions now. What will happen if a crest and crest overlaps, right? What will happen? How will they superimpose? How will they add up at that point of time? So when crest of one wave aligns with crest of another wave, like over here you can see, right? There is crest C1 and there is crest C2. These two waves, that means this one and this one, actually having a phase difference of 0, right? Because they're aligning. So their crest and crest, when are actually aligned, Okay, at that point of time, what will happen? They will have constructive interference. Okay, same interference phenomena only, but they're constructively interfering. And here you can see trough and trough are also overlapping, right? So trough and trough are also aligning, is what I mean, right? Trough of one wave aligns with trough of another wave, right? So trough aligns with trough. At that time, what will happen? Negative peak or trough is the same, so don't confuse. Okay, so when a trough or a trough aligns, it will be destructive interference. Okay, same interference phenomena only, but they're destructively interfering. So you must have seen the bright fringes and the dark fringes, right? You can see it over here on the screen. If you are able to see it clearly, I will show you again. So you'll be able to see that this is the screen, right? So this is a bright fringe, this is a dark, this is a bright, this is a dark, right? You have these spots. Basically in physics we call them as fringes. So what is happening at this point of time? You can see that all these bright fringes are actually coming from constructive interference. All the dark fringes are coming from destructive interference. Okay, so here you can see that there are two waves, one on the left and one on the right, correct? So let's see what will happen if their crest and crest are interfering. That means how superposition will happen. We've seen that superposition is basic addition, right? So I'm going to move these two waves towards each other and see how this crest and crest will work when they overlap. Okay, let's run it. So if you see that they are actually running towards each other, right? And now they are going to interfere. So when they are interfering, I am telling you that they will superimpose, which means they will add up. So can you see what has happened when they add up, right? So this is their superposition. So now they have added up the magnitude of both the waves together, and this is how your constructive interference works. So constructive interference also gives you what? Constructive interference gives you that bright fringe or the bright green spot that you have seen in the simulation, right? So I'm going to run it again, let it go back, and let it come back again and interfere. So these two, one on the left, one on the right, are the simple normal waves which are in same phase. Okay, I'm going to pause it now. You can see that they are moving towards each other, and what will happen now? Interference will happen. Now when interference happen, you can see that amplitude increases, the resultant amplitude increases, right? The wave has added up. So when the wave has added up, you can see that at that point of time constructive interference is happening. So this is exactly what we were talking about in constructive interference. So here again, I'm going to run these two waves towards each other when their trough and trough are going to overlap. That is negative peak, right? So now they're running towards each other. You can see that here also there is an increase in the amplitude, right? So when trough and trough overlaps also, it is what? It is going to give you a, so you can see that here even when trough and trough are coinciding, then also the amplitude is increasing in the negative, right? You can see, I'm going to pause it now again. Yes. So again, so what happens is this is also constructive. So probably I have to correct it over here. So crest on crest is constructive. Okay. Trough on trough is also constructive. So I want everyone to note down the correct conditions now. Okay. I will rewrite it for you. So crest aligning with crest, trough aligning with trough. Both of the conditions are there for bright fringes. That means it's constructive interference. Okay. Now let us also examine the condition, because now I have corrected it. You can write this. Let us also examine the condition where this first wave is actually, if you see, I'm going to use it as -1, and I'm going to make wave 2 as +1, right? Let's check that this exactly as -1. Yeah, so now if we run this, let's see what is going to be the difference, right? So this is crest and trough, right? Positive peak and negative peak trying to align. So when they align, I want you to note down what is the condition. So if they align, you can see that they cancel. right? They cancel because plus 1 minus 1 gives you 0. So this is exactly how your destructive interference will happen. So now I'm writing the correct conditions. Okay, so crest with a trough or trough with a crest are going to give you the dark fringe, which is destructive interference. So I want you to write this in your notes properly, the conditions for constructive and destructive interference. Okay, so just to remind you, constructive interference is what you remember, these spots that we've had, these spots that you've had over here, right? So you can see that over here, this is constructive interference, right? This one is destructive interference. This is constructive interference. This one is destructive interference. So wherever you have a bright fringe or bright spot, you have constructive interference. And on opposite, if you see a dark spot, if you see this one are all destructive interference. So what are the conditions for constructive interference? Crest on crest or trough on trough can align. What is the condition for destructive interference? Crest on trough or trough on crest can align. Okay, so we should know the conditions. I have told you about the conditions over here. Okay, so that's about it. And after knowing these conditions, so now I hope you understand. You can explain constructive interference and destructive interference like using these waves as I have used, right? So I'm again going to explain you. Crest is aligning on crest, constructive interference. Trough is aligning on trough, constructive interference only. Okay, I'm talking about these two. So that's an example of constructive interference. And for example, if crest is aligning with the trough, at that point of time, it is going to be destructive interference. So to make it easy, now first waveform and second waveform, they both are in phase, you can see, because both their crests are aligning with their troughs, right? So I can say that constructive interference is happening over here because crest aligns with crest and trough aligns with trough. So now I'm taking the graph according to length, right? Like I have previously taken. Length means I'm taking it according to the wavelength, right? So what will happen is this part is going to be one full wave, right? Because you have a crest trough, so one full wave you can consider it as one part, and that's why this whole length is going to be lambda. Okay, so I have divided it. The reason I will tell you why. Okay, you know, if this is lambda, this will be half of lambda, right? So now I'm going to shift this second wave and then explain you how it works. What am I going to do? I'm going to shift this second wave. Okay, I'm going to shift this second wave. I'm going to shift this wave. Okay, that is the second wave, right? When I shift it, I will be shifting it consciously by lambda by 2. That is this much shift I will give it. Okay, that means this much shift it will have. Now let's see how that works. Now you can see this is the shifted wave, right? So this wave itself is starting from lambda by 2 if you compare it, right? So what are we able to see? Now this second waveform has been shifted with respect to the first waveform. And how much is that shift? That shift is lambda by 2, right? That shift is this complete area where it was previously there, correct? So can you tell me the difference of length over here that the second wave has with respect to the first one? So this is second waveform, right? And this is the first one. So how much is the second waveform indifferent in terms of length with respect to the first waveform? This much. And this is lambda by 2, right? So this lambda by 2 is called as path difference. Okay. So this lambda by 2 is going to be the path difference of the second waveform when compared to the first waveform. This path difference is denoted as delta x. That is lambda by 2 over here. And this right now you can see that this is the trough, right? One moment. Yeah. So here this part is the trough part and this is the crest part, right? So if trough and crest, you know that they superimpose to do what? Destructive interference. So this is the condition for destructive interference, right? This is the condition for those dark spots that you have seen in that screen simulation that I've shown you on interference. Okay, so for destructive interference, this is going to be the pattern. It can be lambda by 2. Okay, it can be 3 lambda by 2, it can be 5 lambda by 2, so on and so forth up till 2n minus 1 lambda by 2. So this I want you to understand. All this is what? This is path difference, because del x is the path difference. Okay, now let us also explore it for constructive interference. Now what I'm doing is I'm trying to shift this second wave that you can see, okay, for a complete one whole lambda situation. That means previously for this waveform 2, I have used this as the path difference, right? But now what I'm going to do is I'm going to use this whole as the path difference and going to start the waveform from here. Okay, let's do that for the third waveform. So second waveform I have used to explain you destructive interference. Third waveform I will use to explain you the condition for constructive interference. So now you can see this is the third waveform, and in third waveform what have I done? I've used this whole path difference of 1 lambda, right? That is what I have done. How am I supposed to tell you that? Because I'm comparing everything to the first waveform, right? If you can see the first waveform, compare first waveform, third one to the first waveform, you will see that this is the complete path difference of one whole lambda that we have used, and we have started constructing the wave from here, right? So at that time you can see the crest of this first waveform is matching the crest of the second waveform, and trough obviously matches the trough as well. So this is the condition for constructive interference. So this means that I need a I need a path difference of lambda, right? So for constructive interference, let's explore the condition. For constructive interference, it can be 0, lambda, 2 lambda, 3 lambda, up till n lambda. This is the condition for constructive interference path difference, okay? Because this is the whole path difference with which you are able to see constructive interference happening, right? And destructive interference, you have seen it over here for this path difference where trough and crests are matching, and it's going to give you a dark spot. So I'm writing those conditions again. I'm giving you the conditions for path difference. You have understood path difference is basically the length that I have explained you. Okay. For constructive path difference is called as delta x in physics. So for constructive interference is 0, lambda, 2 lambda, 3 lambda. Keep on doing it till n lambda. N values you can vary from 0 itself. So n is equals to 0, 1, so on. Okay, for destructive interference it was actually going to be a lambda by 2, 3 lambda by 2 you can try, 5 lambda by 2 also you can try, up till 2n minus 1 by 2 lambda. Here your n cannot be 0, it has to start from 1 itself. So these are the delta x condition for path difference, and once you know the path difference, there is a formula to know phase difference. This is delta x, okay? This is phase difference, and delta x is equals to 2 pi by lambda into delta x. So I already explained you about delta x, right? This is delta x only. For constructive and destructive, you can substitute and find the conditions for phase difference, okay? So for example, here I'm trying to um, calculate the phase difference for constructive. You know, you will see it occurring in the series of 2n pi only, okay? 2n pi itself, where n can be 0, 2, 4, 6. For destructive interference, if you see phi x, you multiply it with any of the del x value. I'm just going to use you can check and let me know if this syncs fine or not. So here you will have the pattern of phi as 0, 2 pi, 4 pi and so on. And for destructive interference, it will be in the form of 2n minus 1 pi. Okay, here your phase difference will be all the odds. Okay, so I want you to note down these conditions correctly in your notes right now. Phase difference, that is del phi x, right? What is it for constructive, destructive, and path difference is del x. What is it for constructive and destructive? You should know the forms. n lambda. For constructive, 2n minus 1 by 2 lambda, right? And also don't put this bracket for this whole thing, it is only for 2n minus 1. And then these two conditions as well, 2n pi is there, right? And 2n minus 1 pi is also there. So this is the summarization of the things. You can pause the lecture and note it down and check if they are right or wrong based upon the discussion that we have had. For constructive interference, what are the conditions? For destructive interference, what are the conditions of phase and path difference? Okay, path difference is in terms of length, that's why I made a scale of lambda, the graph. And phase difference is in terms of angle, which is why I made a graph of angles as well. Okay, angles as in 0, pi by 2, pi, 2 pi. For whole 2 pi we get one wave cycle, right? And for length, for 1 lambda we get one whole wave cycle, that is crest and trough in one cycle. Okay, and also you should know the relation between these, that is phi x is equals to 2 pi by lambda into delta x. So this formula is very important for us in order to calculate. So if you have del x with you, that is more than enough, you can easily calculate the phase difference. And repeating again, crest and trough, constructive interference, crest trough crest, destructive interference. Okay, that's all you've discussed so far. So now you know why these constructive interference and destructive interferences are happening. Okay, and on the screen you have this pattern, and constructive interference has a different pattern, destructive interference has a different pattern, right? As in terms of the numbers, you know. And if I increase the separation, I'll try to increase the separation between these two. Now you can see more spots on the screen, right? So most importantly, the condition is both these sources, as in these two, right? The light sources, what I'm talking about. For example, this is y1 is equals to a sine omega t. Okay, this is y2 is equals to a sine omega t plus phi. Now you know what this phi is. This is basically the phase difference which we have talked about. These both are having same frequency, same omega, have started at same timing. Okay, then only they are what in terms of physics they are coherent. That means both of them are able to give us a pattern of interference, is what I'm trying to explain. Okay, so this is the interference phenomena where light opts to behave in its wave nature and not in its ray nature. Okay,